Hello millennials and Gen Z. So in our previous video we have covered attention block. Let's move to the feed forward block and try to understand this now. What is the need of feed forward block? As relationship between the different token vectors already established in the attention block by the methods like QKV and matrix multiplication. Can a model with attention block only handles the situation? The answer is no. It cannot handle the real world situation like handling by the ChatGPT 4. Why? Because attention block develops a relation between the token, but it's the linear relation. It means all driven by the specific defined rule in a linear fashion, like language conversion. How are you? This is not exactly word to word conversion in other language. You can test it with your own language. Whatever written in English language not directly converts into other language. In real world, data is related in a complex way, in a non-linear fashion. Hence, feed forward block introduces the non-linearity with the help of functions like ReLU, or it can be GeLU, SeLU, 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 leaky ReLU, depends upon the model architecture. So ReLU, regression linear unit, is simple. If the number is negative, it converts into 0, and if it's positive, then no change. This is one of the method by which we break the linearity. And in simple way, what's the leaky ReLU? If we leave some of the value unchanged, like some of the negative value we do not going to change and do not make it 0, then some of the values gets leaked, right? So it's a leaky ReLU. Let's understand the actual steps in feed forward block. It mainly uses two matrices, W1 and W2. First matrix, when multiplied with the vector, the resultant is expanded version of vector. Second step, applying the ReLU to its expanded version. Third step, again matrix multiplication and compress to the original vector dimension. The result we get is now we are going to add it to the output of attention block. That's the final output of feed forward block. Let's look into the calculation. So here, as we talked about two matrices, so that two matrices is W1 and W2 in feed forward. You remember something, right, by seeing this? So as the input or as the input is a vector, multidimensional vector, the W is matrix. So Wx plus B is the bias over here. Here we use mainly two weights, W1 and W2. First weight is to expand the vector and second weight is to compress the vector again. In this example, for simplicity, we take just 4-dimensional vector, but in actual scenario, we take the matrices in such a matrix in such a way that when this matrix is multiplied by the vector, it expand the dimension of vector. Once that dimension get expanded, we are applying ReLU over there. So first, linear transformation, Wx plus B. So W is this matrix, W into X. So X, this is the final output of the in our previous calculation, right? This attention block, we have already calculated the output for the. So this is the output for the. So it's the W1 weight multiplied by vector plus dimension. So the output is this plus this, final output is this. Now this is the expanded version, as this is the 4-dimensional, because matrix is of 4 dimension. If matrix is of suppose 16 matrix is of 16 4 by 16, something like that, then it gets expanded and have the 16 value over here. So original intention is to expand this vector. So our vector gets expanded. Now applying the ReLU to it. So as we can see, all number is positive. So applying the ReLU, the number is going to be same. If there is any negative number, then it comes to be 0 over here. But luckily here we all get the positive number. If we get negative, then definitely there is a 0. So now go with the second transformation, second linear transformation, that is compression. So W2 into R1 plus bias. So R1 is the resultant from the ReLU function. So that is going to be multiplied by the W2. That is another matrix for compressing the resultant vector. Once calculate this, so again the resultant value gets compressed to the 4-dimensional vector. Okay, now so this is the result of here for the feed forward. This is not the final result. Once we calculate this 4-dimensional vector, then final output is we are going to add this vector to the vector output by the attention block. So we have already know the output vector by the attention block. So we are going to add it to there. So it's like here. Yeah, so this is the final output of feed forward block. Okay, this is the final output. Now the attention output of the is this 1.62 2 this. After adding this to this, the resultant feed forward final result is this 2.60 2.30 2.757 1.337. This is the final output. So as we see over here is the input is 4-dimensional vector, and again the output is 4-dimensional vector. After completing this encoder module, in the next video we are going to cover the decoder module. Stay tuned with the video, as most important things about the decoder module is still need to discuss. Have a good day.